I once watched a perfectly reasonable registry script waste half a day on about 300 laptops. The setting existed. The name was spelled right. The help desk ticket said, "Still broken." The problem was not permissions, replication, or user error. Somebody wrote the value as a string, reg.exe, and the application only honored a reg.d word. Regedit made it look fine. PowerShell could see it. The app silently ignored it. The only reason we recovered quickly was that we had exported the affected key before changing it. Manual registry edits are tolerable on one test machine. At fleet scale, they become folklore. Somebody clicks through Regedit, writes down half a path, misses the value type, then a script copies the mistake everywhere. The naive PowerShell version is not much better. Assume the key exists, call set-item-property, never back anything up, and check only that the command did not throw. That is not verification. HKCU is another trap. It means the current user in that PowerShell session, not every user who signs into the machine. If your support case is about another profile, HKCU may be the wrong hive entirely. The registry provider looks like a file system, but the important mental model is this. Registry keys are items, and registry values are properties on those items. Most broken scripts flip that. They try to treat the value like a child item. So getChildItem finds keys, not values. Get-item-property reads values. New-item creates keys. New-item-property creates or updates values. Once that clicks, the safe pattern is boring on purpose. Test the path, create the keychain if needed, export the native registry path, write the value with an explicit type, then read back the exact property you changed. Here is the pattern I use. First, put the PowerShell provider path in a variable. For example, HKLM:software vendor/app. Use testpath-path key so your log can say whether it already existed. If it does not exist, new-item-path-key-force creates the whole keychain. Before any change, convert to a native path for reg.exe export. HKLM becomes HKLM. HKCU becomes HKCU. Run reg.exe export $native $backup/y. Then write with new-item-property, path-key, name setting name, value 1, property type dword-force. Finally verify with get-item-property value-path key-name setting name. Say the help desk needs diagnostic logging enabled for a vendor app, but only for users who already have active profiles on shared workstations. The vendor documents HKCU/software.contoso desk app value enable log reg.dword1. Do not run as admin and assume HKCU points at the user with the ticket. Enumerate HK users for loaded security identifiers, skipping .default and service accounts if your standard says so. For each SID, build registry HK users/sid/software.contoso desk app. Test pathed, create it with new item force if allowed. Export HK users/software.contoso desk app, then new item property with property type dword. Read it back. Your transcript now shows who was changed. The biggest pitfall is type. A value named enabled with data 1 can be reg.sz, reg.dword, or even reg.tword. Many applications do not complain, they just ignore the wrong kind. Be explicit every time. Second, watch the 32-bit and 64-bit registry views under software. PowerShell 7 is normally 64-bit on modern Windows. Windows PowerShell 5.1 can be launched as 32-bit, especially from old management tools, and then you may land under WoW's 6432 node without meaning to. Third, registry provider paths are local to the session. For remote machines, use invoke command and run the same safe pattern there. Offline hives require reg.exe load and unload carefully. Registry editing is not a replacement for group policy object management, mobile device management, or vendor-supported configuration. It is the sharp tool you use when the setting really is registry-backed, you need a fast repair, or you need evidence for an audit. The provider skills connect directly to earlier object pipeline work. Enumerate targets, filter safely, change only intended objects, capture output. They also connect to group policy preferences, desired state configuration, and compliance reporting. The professional habit is not, I can change the registry. It is, I can prove what was there, what changed, and what it is now. Try this only in a test virtual machine or a throwaway lab profile. Create a harmless key under HKCU, software PowerShell Registry Lab. Use test path first. Run new item path, HKCU, software PowerShell Registry Lab, force. Export it with reg.exe, export, HKCU, software PowerShell Registry Lab, to a file in your TEMP folder. Create lab enabled as a dword with value 1 using New-ItemProperty. Verify with get-item-property value. Then change only the type in your notes. What would happen if an app expected dword and you wrote string? When finished, remove the lab key with remove item recurse, still in the test profile. 3 beats to keep. First, in the PowerShell registry provider, keys are items and values are properties. If you flip that model, your scripts get weird fast. Second, safe writes I'm not complicated. Test path, new item force when needed, reg.exe export, explicit property type, readback verification. Third, HKCU is only the current user. Use HK users when you are fixing loaded profiles that are not yours. That is how registry edits become administration instead of guesswork. New PowerShell episode daily on this channel, moving from first command to real Windows fleet automation.